Good day, this is the Professor, CBMD PhD, and today's Tuesday, October 12th, 2023. It is 2:24 and 25 seconds a.m. Eastern Standard Time, and today's research, Ethereal view. So let's hop to it here. This is Web captures an Ethereal view of NGC 346, date October 11th, 2023. Source: NASA Qatar, Space Flight Center. One of the greatest strengths of NASA's James Webb Space Telescope is its ability to give astronomers detailed views of areas where new stars are being born. The latest example showcased here in a new image from Webb's mid-infrared instrument is NGC 346, the brightest and largest star-forming region in the Small Magellanic Cloud. The Small Magellanic Cloud is a satellite galaxy of the Milky Way, visible to the unaided eye in the southern constellation Tucana. The small companion galaxy is more primeval than the Milky Way in that it possesses fewer heavy elements, which are forged in stars through nuclear fusion and supernova explosions, compared to our own galaxy. And since cosmic dust is formed from heavy elements like silicon and oxygen, scientists expected the Small Magellanic Cloud to lack significant amounts of dust. However, the new MIRI image, as well as the previous image of NGC 346 from Webb's near-infrared camera released in January, show ample dust within this region. And this representative color image, blue tendrils, trace emission from material that includes dusty silicates and sooty chemical molecules known as polycyclic aromatic hydrocarbons. More diffuse red emission shines from warm dust heated by the brightest and most massive stars in the heart of the region. A dark at the center left may be a reflection of light from the star near the arc's center. Similar fainter arc appears associated with stars at lower left and upper right. Lastly, bright patches and filaments mark areas with abundant numbers of protostars. The research team looked for the faintest stars and found 1,001 pinpoint sources of light, most of them young stars, still embedded in their dusty cocoons. And by combining Webb data in both the near-infrared and mid-infrared, astronomers are able to take a fuller census of the stars and protostars within this dynamic region. The results have implications for our understanding of galaxies that existed billions of years ago, during an era in the universe known as cosmic noon, when star formation was at its peak and heavy element concentrations were lower, as seen in the Small Magellanic Cloud. And this is a professor of space technology, astronomy, advanced physics, mathematics, computer science, and leader of research. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.